My name is Patrick McCory, and today I'm going to give you a small, brief vision of what I think cryptocurrencies are going to do over the next couple of years. I think they're going to be an open source, global permissionless, and off-chain financial network. Now, I've been doing research on off-chain protocols for the past 4 years, so thanks to all these wonderful people, they've helped me build this vision up of how I think this is going to, come about and evolve. So as most people are aware, cryptocurrencies don't really scale that well. You're all hopefully knowledgeable on that. Bitcoin and Ethereum support on the magnitude of 10 transactions per second. And why is that? Why don't they scale? So everyone has a different take on this. And this is mostly my take. It's a trade-off between the diversity of users who can afford to use the network and the diversity of validators of who can hold the miners accountable. So that's a really good example of this. So so let's talk about Bitcoin versus Bitcoin Cash. So as most people are aware, Bitcoin Cash want big blocks. You can have a 1 gigabyte block every 10 minutes. And that's great. If we have 1 gigabyte blocks, you would like to think we could support 100 TPS, 200 TPS, and the transaction fee should remain low. If they remain low, Alice can pay Bob for coffee for 1 cent. So we have a huge diversity of users who can afford to use the network. The issue is validation. Who can hold these miners accountable? Who can validate that the blockchain really is the blockchain and not something else? So if you want to have a 1 gigabyte block every 10 minutes, my humble MacBook Air, it lacks the computational resources or the bandwidth to process a 1 gigabyte block every 10 minutes. If I can't process it in real time, I have to trust someone to validate the blockchain on my behalf. Then we get to the other extreme, the Bitcoin extreme. If there's a 1 megabyte block every 10 minutes, great, I can validate 1 megabyte block every 10 minutes. But the trade-off is that once you reach once you go past 10 TPS, so once you reach the network's throughput ceiling and you take up all the block space, fees skyrocket from 2 cents to $20. So out of here, who wants to pay $20 for a Bitcoin transaction? No, okay, no Bitcoin maxis here. Awesome. I'm only joking. But that's a big deal because, well, we can validate the network, we reduce who can afford to use the network. So something like Bitcoin really is only useful for users with a high net worth who are willing to pay $20 for a transaction. And we don't want to build that. We want a global payment system anyone can use. So how can we scale the network? So it could be centralized, but I've crossed that out. We're cypherpunks. We don't want a single centralized solution. So some people propose different consensus protocols like DAGs or, I'm just going to say DAGs for now, different blockchain structures where you could strictly increase the throughput. And that's great, they can increase the throughput. But then they run into the dilemma of who can validate the network. Then we lose the one thing that makes cryptocurrency so beautiful, that we don't have to trust anyone. Then there's sharding, ETH 2.0. And what's really nice about sharding is that you can have a shard for hotel bookings and a shard for train bookings. So you distribute out the task of validation. But if you care about hotel bookings and train bookings, you're sort of stuck validating everything anyway. So you distribute out the task, but you don't get rid of the problem. So what's really exciting about off-chain protocols is that the way they scale the network is a really simple intuition. Why do we send every transaction to the network? If Alice is paying for coffee from Bob, why does that need to be processed by the global network? Can we do it in such a way where Alice doesn't have to trust Bob? There's no counterparty risk. And there's 2 ways we're going to do this, and I'm going to go over both approaches today. Okay? So why is off-chain exciting? So it's exciting because there's one transaction to join the off-chain protocol, and hopefully by the end of the day, I threw this huge number in here because every blockchain project likes to do that. I'm going to demonstrate how we could actually achieve something in that range of 100K transactions per second, let's say. Why is that? Because off-chain is the only scaling solution where 99% of all transactions remain local between the parties, between Alice and Bob. They never have to touch the global network. If you don't touch the global network, you avoid all blockchain latency, and you don't have to pay any network fees as well, because it's only between Alice and Bob. Now, the goal is to ensure we still retain the non-custodial security guarantees. No counterparty risk, so that Alice doesn't have to trust Bob. And if we can achieve that, then we can hopefully scale these networks. So let's walk through each building block step by step. So off-chain channels, who's heard of channels before? Most people have, okay, so I can be quite brief about this. But they're fairly straightforward. There are 2 parties, typically Alice and Bob, and they have a symmetric relationship. And what one or both parties can deposit coins into the channel. So in this case, Alice will deposit in 1 coin. And now the channel's set up. Typically, both parties should agree to set up the channel. Now, OneCoin's locked into the channel. Assuming both parties agree, now we can progress off-chain. So Alice can pay Bob the OneCoin here. So Alice can send Bob the OneCoin. Alice signs off on it. Bob signs off on it. The coins are sent to Bob. And what's really cool is that we can just keep doing this back and forth. So we can do this thousands of times. The global network has no idea this is happening. And they're just sending the coin back and forth rapidly. At the end, they can close the channel, and they can get the coin back out. Now, what's exciting is that in the Bitcoin world, it was mostly for payments. In the Ethereum world, we can generally have this as any fixed party smart contract. So when you have a smart contract for two people, you could take this off-chain and run locally between both parties. This could be auctions, casino games, e-voting, bidirectional payments, etc. I'm very bullish for the payment case. I still think payments is the best use case for channels. Now, what can we build with this? Okay, so we have a mechanism where Alice and Bob can lock coins into a black box, redistribute that deposit back and forth. Why is that useful? So what we can actually build is a channel-based network. Okay? And that's the Lightning Network. So right now, I took this a while ago. It had 40,000 channels at the time. So why is this important? Oh, before we can build this global network, we still need one primitive. Okay? And this primitive is called the humble conditional transfer. Now, this is going to look a bit stupid to begin with, but bear with me. In a few slides, it will make complete sense why you would do this. So you have Alice and Bob again. And Bob is going to generate a secret R, which is a random number. He'll hash it, and he'll send the hash to Alice. What Alice is going to do, she's going to set up a conditional transfer to buy the secret R. You know, why you want to buy a random number seems a bit silly, but she's going to do it anyway. So she's going to say, Bob, if you reveal this secret before time t, you get one coin. And now what Bob can do is he can reveal the secret R, Alice can get the secret R, they can both cooperate, and they can remove the condition, and Bob will get the one coin, and Alice gets the secret. Now, if they don't cooperate, let's just say Alice gets the secret and says, sorry, Bob, I'm not going to give you the one coin. How can Bob guarantee he always gets that one coin for selling the secret? Well, all he has to do is get the signed conditional transfer, he gets the secret, and he broadcasts both to the blockchain. It gets confirmed, then the blockchain will say, well, Alice agreed to the conditional transfer before time t. Bob supplied the secret. Let's give Bob the one coin. And that's really cool. Now, the blockchain can be used to resolve these disputes. You know, given some evidence, it will guarantee Bob always gets the coins. So now we have this conditional transfer. Okay, what can we do with this? How can we build this channel-based network with the conditional transfer? What we can do is that if Alice has a channel with Bob, Bob has a channel with Caroline, and Caroline has a channel with Dave, Alice can pay Dave via Bob and Caroline in an off-chain manner without any counterparty risk. So this is basically a path-based payment. We're given a path in the network, you can synchronize a single payment across that path. You can also do virtual channels, but I'll talk about that today. Oh, it's called a hash time lock contract. Oh, if you have any questions, by the way, please throw questions at me. Yep.
Yeah. I experimented a bit with Blue Wallet,
yeah,
with Lightning transactions.
Yep.
And there's one thing I was wondering exactly about this problem. Say I sent 5,000 Satoshis or whatever to
yep.
a friend. He said he never got it. So how would I prove it? Because I cannot see it on the chain.
So what should happen? Oh, can you hear me? No?
No, I would like to hear the question.
Oh, okay. So he's basically asking on Blue Wallet, you have a Blue Wallet, your friend has another Blue Wallet, I assume. You're trying to send him a Lightning payment and he never got it.
Or
so
let's say he claims he never got it.
Oh, he claims he never got it.
He claims he never got it. How would I be able to
verify that?
It was not my friend, but it was just somebody.
I think there's 2 points of that. So Blue Wallet is custodial. So you're not really using payment channels there. To an extent if you're both on the same service provider. What should happen is that your friend gives you a signed receipt and he generates the secret. You know, he gives you a signed receipt to say here's an invoice. As long as you pay the invoice, only he should ever have the secret. So because only he has the secret, If I send a payment on the network and it gets redeemed, only he could have redeemed it. So what you can say is, I received this invoice from you, I send a payment to the network, and it was redeemed. You're the only person who should know that secret. Because you're the only person who knows that secret, you must have claimed the payment. Does that make sense?
There's a microphone on the right there. If you can use it for questions.
Oh yeah, of course. I can also hand this out. Yeah, let's pass this round. Does that answer your question?
Yeah, it's just like it's just in the UI of Blue Wallet.
Yep.
No, in the UI of Blue Wallet, there's no real way in kind of determining that. You know, that's just like.
Yeah.
But basically in theory, it should work, and
it should work. Yeah. Assuming you have a signed invoice from the user and you've sent the payment to the network, only they could have ever redeemed that payment.
Okay.
So you rely on that fact.
Okay.
So I don't know if LND or Eclair also have the invoice. Babe, I mean, I receive invoices when I pay people, so I have a copy of the invoice at least. Cool.
Okay, thanks.
Any other questions, by the way, before I move on?
Yeah. So the channels sounds great if Alice or Bob is like a big bank where they're doing a lot of transactions. But what if they just want to transact once? Surely the fees would be basically a
We're going to get to
fee.
this. We're going to get to this. So what I see Lightning being useful for is as a routing network. I don't think it's very useful as a payment network. So this is going to sort of answer the question shortly when I talk about commit chains. Commit chains is probably where 99% of transactions will happen for most users. And this routing network will just be between hubs. A bit like Visa. Okay, any other questions? Cool, okay. So what does this look like when Alice pays Dave? You know, at a very high level, Alice sends one coin to Bob. Bob's going to send one coin to Caroline. Caroline's going to send one coin to Dave. Now, this is all done using conditional transfers, but I've not included that in the slides because of time constraints. But yeah?
What does it mean, the one so you have two rows there? What does it mean, the one above?
Yeah, so what's important is that in this channel, so let's go through it step by step. So Alice has a payment channel with Bob, and Alice can send one coin to Bob. Okay? So Alice does that. She'll send the one coin to Bob. Now Bob's going to get a different coin that he has with Caroline, and he's going to send it over to Caroline. And then Caroline has a different channel with Dave, and she's going to send that one coin to Dave. So all I'm highlighting here is that on Lightning, or the channel-based networks, when you're doing this path, you're not actually sending the one coin across. You're just redistributing these deposits that these people have. Does that make sense? Cool. Yep.
Are you redistributing the secret to?
Yep. So what happens is that you set up the path, and then the secret comes backwards. And then all these transfers happen in the reverse order. Yeah, I should have shown that slide, I guess. I removed it because of time. Cool. But yeah, so that's basically how a Lightning payment works at a high level. You're just redistributing these deposits between each party. Okay? But channels are not very good for payments. Why do I say this? So who's tried to use Lightning before? Okay, you all have. So who enjoyed the experience of going on Bitrefill, you know, opening a channel and paying for the privilege to have incoming capacity, and then only being able to receive up to 2 coins, let's say? Did anyone enjoy that experience? No one did. Okay, awesome. So the problem of these payment networks is that if I want to receive coins, I have to have incoming capacity. And that restricts how much I can actually receive on the network. So let's consider an event. I'm running an event. I'm selling every ticket for 1 coin. I sell 100 tickets. I need, on the network, enough incoming capacity of up to 100 coins to actually sell my tickets. So if I'm receiving lots of payments, but not sending much, it doesn't really work well for my use case. You know, I have to pay for this privilege. But what it does work really well for is when there's a coin going back and forth rapidly like this, as I showed earlier with Alice and Bob. So actually what this is a routing network. Okay? So you can imagine several paths all being set up at once, being set up and executed exactly at the same time. If this graph became big enough, hundreds of paths can be set up and closed at exactly the same time. So the throughput limitation there is based on the size of the graph and the capacity within every node in that graph. So it could actually achieve a ridiculous throughput. I normally call it Visa on steroids. But the question is, where's A and B? Where are we sending the coins to and from? If it's not being used for payments, there needs to be some reason to have a routing network. Okay? Oh, on this slide. So now we're going to say, well, what if most people use hubs? You can imagine large exchanges like, Binance, Bitstamp, Gemini. They all run their own payment channel hubs. They remove all counterparty risk for their customers. Why don't they use payment channels? So payment channels aren't very good for hubs. So if you consider this very simple example, the operator has to have a big pot of money. And every time a customer comes along, so Alice, the operator has to decide, out of my big pot of money, how many coins am I going to allocate to Alice? In this case, he'll allocate 2. So now Alice can receive up to 2 coins. In this case with Caroline comes along and the operator says, well, I don't want to give any coins to Caroline. So you can open a channel, so you can deposit 1 coin, but now Caroline can't receive any coins. So you can just send coins in the hub. So this is pretty much like Bitrefill and Eclair at the moment. But they're not very good for hubs. There's way too much collateral involved, because you can lock coins here, and then Dave doesn't do anything. And now you've just locked up 4 coins for a couple of days, and you have opportunity cost loss, But what is really good for hubs are commit chains, like Plasma and NoCo. So who's heard of Plasma before? Who thinks Plasma will ever get built? Okay, 2 people. Good. It will get built eventually. So does anyone understand Plasma? Okay, cool. So I'm going to give you a very brief overview. So as a non-custodial operator, my only job is to collect transactions that occur on my service, create a block, and post a little block hash or a checkpoint to the blockchain. So this is a checkpoint, and it's just a list of transactions in a very abstract sense. So Alice comes along. Alice will deposit 1 coin into the Plasma operator. And then Bob comes along, hi Bob. And then what Alice is going to do is via the operator is send 1 coin to Bob. So you'll sign it, give it to the operator. The operator can notify Bob to say, oh, Bob, you received 1 coin in an off-chain manner. Now what the operator does is wait around for more transactions. There could be thousands or millions of transactions here. And all they do is wait around and collect these transactions. And what they'll eventually do is create a block and post a small checkpoint, which is just a hash. They post a little hash to the blockchain and say, here's a bot confirmation of all these transactions. And they just keep doing this periodically. Now, what's really exciting about these non-custodial operators, there's no collateral lockup for the operator. Alice put in the money, not the operator. What's also nice is that their only job is to collect transactions authorized by their customers and do bot confirmations via the blockchain. And it's non-custodial. If they're built in a secure manner, they can never steal the customer's money. So what's really cool here is that we now have this channel-based network that would allow you to send coins across across hubs and without any counterparty risk whatsoever. Then you have these commit chains. Now they're slower because you rely on these checkpoints to reach the blockchain. What an operator could do is censor you. They may just not include your transaction in a block. But that's fine. If they don't include your transaction, you withdraw your coins and you just go to a different commit chain operator. So there is this asymmetrical relationship here, and there's some risk of censorship. But you can just move away because they just can't block you or steal your money. Okay? But all of these protocols have one fundamental issue. The user must remain online and synchronized with the network to protect themselves. Okay? And that sucks. So let's give an example. Alice has $1 million in the Plasma Hub operator. She goes offline, let's say, and then Bob tries to cheat. Bob's going to say, I'm going to reverse your payment, or I'm going to steal your money. So what could happen is that Bob will trigger a dispute on the blockchain, and now there's this fixed time period for both parties to send evidence of the latest balance. So Bob's going to send old evidence, where he's going to reverse some payments that Alice did, or what he did to Alice. He wants to get all of his coins back. Then the blockchain starts ticking. And Alice says, will Alice wake up to save the day? Will Bob get away with it? Da, da, da. Oh, I'm missing a slide. Okay, what does happen is that Alice responds. So he gets to keep her $1 million. So he's a bit embarrassed, but Bob lost out. So Bob didn't get away with it. But it's not a realistic assumption to assume Alice is always online, synchronized with the network, and watching out for these disputes. That's a terrible user experience. So what we worked on 2 years ago was basically something called PISA, or more generically called these Watchtowers, which is a trust minimized third party. The idea is that they take on the financial liability while you're offline. Okay? So what happens is that, yeah, I'm definitely missing some slides. So what happens is that what Alice will do is before she goes offline, she's going to hire PISA and send PISA the evidence that would need to be broadcast. PISA in return would give a signed receipt. A signed receipt to acknowledge that they've accepted the job from Alice. Now what happens if Alice hired PISA, Alice goes offline, and PISA doesn't protect the customer and doesn't respond on the customer's behalf? What would happen is the following. Alice has on-chain evidence that PISA did not do his job, and it has a signed receipt that PISA promised to protect the customer. And this can be sent to the PISA contract. Now the PISA contract has a security deposit to prove that it has some skin in the game and is not going to cheat. Now what this will trigger is a refund period. PISA can refund the customer a pre-agreed amount, that financial liability I spoke about, and then PISA can send the refund. Oh, there we go. My slides are messed up. Okay. Now what would happen is that if PISA doesn't send the refund, and we go past this period, then PISA will get sloshed and lose a security deposit. So it's a financially accountable third party. And it's more like insurance. If you're insured, you're driving a car, you're insured, you still take care on the road, but as a last resort, this third party will take on the financial liability and try to protect you. Yep.
Where does the security deposit go if it's slashed? Where does that go to?
Yep. So there's two ways. Okay, so I can repeat that question. So the question is, where does the security deposit go? What if you can prove something like PISA cheated? So either it gets completely burnt, PISA loses that altogether, or there's an alternative where you could use the security deposit to refund the customer. Yeah, so you could do both. I prefer the sloshing approach because it's just clean. Yep.
What if the deposit is smaller than?
Yep, so what if the deposit is smaller than what you're protecting?
Yeah, exactly. Then PISA is not incentivized in fact to not cheat.
Yeah, so in this case,
You could be bribed.
you could be bribed, yeah. So what you're effectively doing here is that PISA has this financial deposit, but it also has a reputation. It's a repeated game. As long as I keep running this service, I'm going to keep making money. That's, I guess, the simple answer to it.
I guess the amount of the security deposit is also transparent. So
Yep, completely transparent.
how much is in there before she uses
Yep. So before you enlist PISA, you can see what a security deposit is going to be. Ideally, it should be a fairly large security deposit. So let's just say I have a payment channel of, $500 or $1,000. Really, this should be like 50K, 20K, 100K. Ideally, it should be some magnitude larger. Yeah, but at some point, it could be some fractional reserve, which is, I guess, how most systems work anyway. Okay, any other questions at this point, by the way? Okay, everyone's quite happy with that. Cool. Let me just find my, yeah, I guess that's mostly it. So this is basically how it should work. Alice goes offline, PISA responds, Alice comes back online. It's fairly straightforward protocol. Now, what I do want to get to is this picture. Okay? So as I just, yep.
So,
Sorry,
could you go back? Could you go back to the previous slide?
Yeah.
So whenever Alice transacts, she needs to send the transaction both to the channel, to the let's say Plasma channel or Plasma operator, and to the PISA. So PISA have to collect all the evidence.
Yep. So PISA should always have the latest evidence to send. So one thing I should mention is actually privacy. So something like a third party, this accountable third party, it inherits the privacy of the protocol you're using. So in state channels, all we would receive is a hash and a signature. So you don't actually learn what app you're running or what you're doing. In Plasma, so far, Plasma doesn't have any privacy built in. I have some ideas on how they add privacy to Plasma. And assuming I get those written up and released, then you could hire a Watchtower in a way where they know you're using this operator, but they don't know your balance on the operator. So yeah, all Watchtowers will always inherit the privacy of the underlying system, which is nice. Does that help with the question?
Yes, but it's not satisfactory in fact that we don't have a solution.
Well, for privacy.
Yes.
So there's privacy for state channels. There's just no privacy for these plasma operators here. Where am I? There's no privacy for this yet. So normally the way I describe commit chains is that it's sort of like the Lightning Network in 2016. We know it exists. We know how to build it. We know the rough design space. But there's going to be so much better protocols emerging over the next year or two. I think it's very easy to have privacy here. So I'm not actually worried about that.
Is there any zero knowledge proof based Plasma?
So normally you have Plasma Snark, but actually all that's doing is he's given this checkpoint. You have the hash and a snark to prove this is well formed. So there's no fraud proofs. It's not used yet for privacy. But I think you could use it for privacy.
CK rollup, also an example?
Yep. So ZK rollup is basically where you post a checkpoint on all of the data in a compressed form. So there's still no privacy there. Because all the data is publicly on the blockchain now. But yeah, but you're also using the snark to prove that the witness and the data matches. Yeah. So the next step is adding privacy to it. And I think that's doable.
Why is it not private? If you only have to prove that the batch.
So in rollup, okay. So he's asking why is there no privacy in rollup? So when you look at commit chains, you have a smart contract here, and it does two things. It first has to check the integrity of the checkpoint, then it has to guarantee that the off-chain data is available. As in, if you have one coin on this plasma operator, you need to know you have one coin. Now in rollup, they weaken the data availability assumption, where the operator must post all data to the blockchain. So if you're doing 1,000 transactions, compressed data has to be posted to the blockchain. So all the data is public on the blockchain for rollup. Yeah. So that's why you don't have any privacy, because it's publicly available for everyone. You'd have the big privacy into the Plasma protocol.
All data. Sorry, he needs to push all data on the blockchain? I mean,
yeah, that's the rollup approach.
Will it fit into the transaction? I mean, there will be lots of data.
So this is why I'm not very bullish. I mean, I think rollup's a cool idea in the short term, because it's much easier to build. But long term, it's not a super scalable solution. The underlying blockchain becomes more of a data availability layer, when really it shouldn't be accepting all that data. So there's still a throughput limitation. Any other questions or? Cool. I like the skeptics. It's good. Okay, cool. So this is basically the off-chain landscape at the moment. I don't know how those slides get mixed up. I've used these slides before. Okay. So what I want to highlight is that we're going to have this channel-based network. Okay? Where anyone in this room, who opened the Lightning channel, by the way? Who's actually opened Lightning channels before? 1, 2. Cool. 2 people. I mean, we're in an Ethereum conference, aren't we? It's for anyway, so what's cool is that it's truly peer-to-peer. Anyone in this room can go open a channel and participate in this routing network. You put up some collateral, you advertise your service, and you can start routing coins back and forth. Assuming this graph, the topology grows large enough, the throughput limitation is very difficult to compute. It could actually achieve somewhat the 100K TPS, because it's just these paths that are all local between the parties. You never touch the global network to route a payment. That's cool. Then you have these non-custodial operators. If you use something like Plasma, anyone in this room could set up a Plasma instance, your customers start depositing coins, and your only job is to coordinate and bots confirm these transactions. So this non-custodial operator could actually have millions of customers on their service using transactions on cryptocurrency, but never actually interact with the global network. At some point, they'll support smart contracts, and at some point, they'll have some privacy. And in the middle will be this watching network that basically takes on the financial liability for users who want to go offline. Long term, I suspect hubs will hire the watching network and not the end user, because they're just they're normies. They don't want to care about watching networks. And this routing network, they'll probably also hire the watching network, but they're more like pro routing nodes. Now this all sounds fake. Not fake. It sounds like a vision that doesn't really exist, but actually it's being built. If you look at the companies building in this space, you have all these. That's actually not even all the channel-based companies. They're all sort of building a routing network, and they have no idea that they're actually doing it. Most people still look at Lightning as a payment network, when actually channels work best for routing. You have these non-custodial operators emerging, like Starkware, Plasma Group, Liquidity Network. They actually have a mobile wallet now you can play with, and they're being built and emerging. And now I guess PISA is finally building the watching network that doesn't exist yet. So within the next year or two, I suspect most people actually get to play with this and try it out and see how well it works in practice. I think our main obstacle as a community is software confidence. If you're a large exchange, are you willing to run this software yet? There could be bugs. They don't fully understand it yet. So our job is to educate and make sure they're aware that it's actually much better than what they're doing now. Because there's no counterparty risk. I don't have a hot wallet anymore. It's great. Cool. And that's my last slide. So the goal of PISA is to go towards an off-chain, non-custodial, global, permissionless, and truly peer-to-peer payment network. And hopefully within these 30 minutes, that's normally an hour talk, I've given some intuition of why this could be truly peer-to-peer for the routing network, why it could be non-custodial, and why it could actually scale to some TPS that most blockchains claim they can do. So yeah, do you have any questions? Cool. I think everyone's tired then. Yeah, I'll be around for the next hour anyway. I've got to leave after lunch. So if you want to talk privately about this, I'm more than welcome to answer questions. But anything about Plasma I can answer as well. Oh yeah. Oh, sorry. I do have one question then.
What do you think about the interoperability solutions like Polkadot and Cosmos? I think that they use some off-chain approach plus some way to integrate different blockchains.
Yeah. So the main difference between sharding and off-chain protocols is that in sharding, you assume the verifier has full computational resources and storage. Where off-chain, you assume the validator only has limited computational resources and storage. And there's a third party who can do it for the verifier. So I think they're going to, they are going to be deployed and used, but I don't think they can compete with the scalability of off-chain. Because of the very nature that everything's local here. Where in Cosmos, everything's global.
Yeah, but in Polkadot, there is, I think it is like a hybrid solution because many of the relay chains, or how was it said, parachains, are kind of private and kind of off-chain solutions, in my opinion.
Yeah, they'll be off-chain. It just depends if they're non-custodial or not. I mean, this is going to be the one thing we're going to see over the next coming years. Do people care about this? Do you want to build a system where you don't have to trust the operator whatsoever? Yeah. Or are you happy to trust a federation to run the sidechain for you? And that's going to be the big test in the next coming years of whether users care about that or not. Maybe they don't care about being non-custodial. I know a lot of companies do because then you remove liability. But anyway, yeah. So that's my answer. Yep. Oh, can you pass the mic?
Yeah.
Following your question, I think it would be possible to build. I mean.
Oh no, you can definitely build this in Polkadot and Cosmos.
Right.
These are generic. They work on all blockchains, and actually, once you're in the off-chain layer, you don't really care. There's always one node in the middle who could. If I'm in let's just say I'm on Bitcoin and Ethereum, I can be the bridge between the two blockchains, and I take on the exchange risk. So they work on all blockchains.
Exactly.
Yeah. Cool.
So,
I'm glad you brought that up. There's a case that didn't come across that way.
With Polkadot, I think that they were talking about getting rid of the whole notion of fishermen, though, because of the speed issues. So does the Watchtower have similar issues in terms of like slowing down how quickly transactions are synced?
So ideally, the way the watching network should work is that there should be a watching network with multiple watchers. And ideally, there should also be watching pools, where it's like a mining pool, but for watchers. If there's just one large watcher on the network, then yes, because there'll just be a bottleneck. Ideally, there should be several large watchers where, and actually, I guess it centralizes, and it centralizes always faster. So, so maybe, it depends if we can compete with the peer-to-peer network or not. But yeah, maybe a large watcher could be some bottleneck.
Okay.
Yep.
Any UX downsides to this?
UX?
Yeah, any like user experience things that no ideal?
Okay, so I think for this watching network, if you're using this alone, then yes, the UX of Lightning is not very good at the moment. I think everyone can admit that. If you're over here, you don't even need to know you're using a blockchain anymore. I just give you some token. It's on the Plasma operator chain, whatever. And this is a normal UX experience. It's as if you're using a custodial server. The difference is that you're holding your keys. Ideally in the best case. Using the watching network, this is why the hubs should be hiring the watching network and not the users. Ideally, we release an API. We have an API now. We give it to the hub. They plug it in. And these users have no idea they even have a watching network backing them up. Because we really don't want the user paying a subscription for this. That would suck. Yeah.
Oh yeah, so you were saying about them having PISA Watchtowers having skin in the game. So what kind of fees are they looking to be earning from that kind of role?
Yep, so it depends on the liability we take on as a watching network. So if we're insuring you in a sense for like $100,000, then there'll be some higher subscription for that. That's, I don't know, 5K, 10K or something. It'll probably just follow similar insurance schemes that they have today. That's still a work in progress. You only learn that when there's a market.
So could anybody become a PISA Watchtower?
Yeah, everything we have at the moment is open source. We've done that on purpose because there should not only be one watcher. Ideally, if we write the software and we run it, you'll like to think people will come to us and use our service. But yeah, ideally there should be more than one watcher. And we hopefully have. So with our Ethereum Foundation grant, the condition is that everything's open source at the moment. To help towards that goal.
Does that mean that there'll be kind of an open market for whatever fees are charged by each Watchtower? So you'd find a fee market would
there should hopefully be a fee market. I think so when watching networks were originally proposed, the idea was that they would collect bounties. So if there is a dispute, that's only when I get paid. I collect the bounty and I get it. The issue there is that if there's a single bounty and you've hired 1,000 watchers, they're all competing for this one job and only one person gets paid. So it's good for decentralization, but it sucks for watchers because they have all these stories overhead and they might not even get paid for the job. So on the other hand, for us, we get paid up front for doing the work, and we just watch them respond, but we don't get paid for the response. Maybe we get refunded, I don't know. But I still think the best customers would be large hubs. It'd be some subscription model where maybe they pay 5K per month, and they get this nice guarantee. Yeah. Any other questions or? Cool. Good job, guys.